Oh, apparently I can't spell.
Yeah, apparently not. Hey,
Just
Kevin.
Making fun of me.
sorry, we have forgiveness.
So let's think of this mid-segment. Let's use vocabulary strategies to figure out what is the root.
The middle.
The middle of the triangle.
The middle of a segment.
Mid-segment.
So where do you think these segments, just by reading them, where do you think they might be constructed from? Yes, sir. The middle. The middle of what? Which segment?
The bottom. Triangle. And then triangle. The triangle, like the bottom of the triangle.
Which one's the bottom?
The hypotenuse.
Is it a right triangle? Which one's the bottom? Do I know which one's the bottom?
No, you don't.
I don't.
Anyone can be the bottom.
Anyone can be the bottom, right? So that means what?
Yeah.
Does it mean pick the smallest? How? So if I don't know which one's which, what side's what? If I don't know which part it is, if I'm just going to sit there and let it spin around, how do I know where these segments are? Well, here's what happens. This mid-segment connects the midpoints. How many midpoints can you have in a triangle? 3 of them, because how many sides do you have? It's convenient, isn't it? So the mid-segment. It's a segment that connects midpoints. Now, if you have a midpoint, bless you. Bless you. Remember, a midpoint is the halfway point on a segment. It does not necessarily mean that all of your sides of a triangle are always going to be the same, so I don't know that, but I do know that I can set it up excuse me, in such a way that I have 3 spots, 3 midpoints. Now, here's what happens then. There's the segments that connect midpoints. So we go across here. We have one down here. I have another one going that way. There are 3 of them. Okay? Now, what happens is 2 things. First thing, it is parallel to the side it doesn't touch. Okay? It connects the midpoints, parallel to the side it doesn't touch, and it's equal to half that length. The mid-segment equals half the side not touched. And there's 2 ways I want you to write that. So if this whole segment here is 12, what would the mid-segment be?
6.
I know we're pacing ourselves. You okay? I don't want to make this too difficult here. Notice that segment does not touch that 3rd side, and it's parallel to it. Now, going the other way. If the interior mid-segment is equal to half the side it doesn't touch, what if I give you the mid-segment?
8.
How much is the other side? 8. You just double it. Which means the other way you can write this is if you double a mid-segment, it equals the side not touched. That's basically what we're looking at today. Okay? No, it really is. Okay. Going from what we've been doing to this, it's a nice change of pace, shall we say.
It's real smooth.
Okay?
It's real smooth.
So, mid-segments, make midpoints. So the mid-segment is half the side not touched. Or you double the midsegment to equal the side. What's that? Oh, how about I do this?
Yeah. Oh,
Does that make it easier? Okay, that's all it means. All right. So algebraically, I mean, this stuff is really, really easy. We probably don't even rewrite this out. Now, if TU is a mid-segment, what does it equal? 5. Everybody okay with that?
Yeah.
Pretty quick. What I want you to see, though, is how much is SQ and how much is SP? They're both 5, aren't they? Now, if this is 8, how much is the whole thing?
Wait. Sorry, goodness gracious.
It's okay. Nobody's mad at you. He might be. Looks like he's testy. He gets doesn't like people.
What's the next episode?
So that means this whole thing is 16. Now what's half of 16? Which means these are both 8 and 8. Now, for fun, let's say I did this. Oops. Let me draw it in where it works. Never mind. So let's say I draw that in there, and I say that that's equal to, I don't know, 7. How much is RQ? 14, which makes each segment how much? 7. Now notice, in this diagram, 7 is equal to 7, 7 is equal to 7. How many tick marks is that supposed to have?
2. It's 2.
One.
It's 2.
I said 2.
5 is equal to 5, which is equal to 5. How many tick marks does that get?
1.
8 is equal to 8. How many does that get? Notice you wind up, when you connect all 3 mid-segments, you get 4 congruent smaller triangles. Okay? You get 4 smaller congruent triangles by side, side, side. Okay? It's exciting, isn't it?
It's sensational.
Okay. What you're looking at here, as you start to go through it, is a very simple reason why this algebra works. What happens is, let me draw this again. We draw these in. Parallel, touch, touch. If I call this, we know these are midpoints. If I call each one of these x and x, how much is the whole thing? 2x, very good. Now the mid-segment is equal to half the sides it doesn't touch. So if the whole side is 2x, how much is the mid-segment? Which means that it is equal to the other two, like that. That's why that works. Okay? That's why that works. You can go the same thing. If I call each of these y, what's the whole thing? 2y. This is the mid-segment, so it's equal to half of what it doesn't touch. What's half of 2?
1y.
So it's just 1y. And I do the same thing with z's. Not these sleeping z's. There's a joke again.
How did you get it?
That's why this stuff works, guys. So if you look at it that way, you do get, excuse me, you do wind up with those congruent triangles that way. All right. Yeah. And there's a couple ways you could have done it, but this is just a real basic way of why that works, because of all that. Now, excuse me, don't worry, I'm not making you do any proof. probably won't even, we could do stuff with coordinate proof, we might, I don't know, it depends how much time we have when we get back from breaks.
No, you promised.
We do.
You promised no proofs.
Coordinate proof is different than proof.
Right.
Coordinate,
Same thing.
coordinate proof is, using ordered pairs and like walking through a diagram, it's not. So let's just jump right to what you guys are gonna be, always gonna get PO'd at because you don't like to do algebra. So let's just jump right to algebra. So let me redraw this diagram so you can see it better. Actually, this.
It was too wide. Too wide. No, this was 2x.
Okay. So here's what we've got. We have U, V, and W are midpoints. If those guys are midpoints, that means the segments that connect them are going to be mid-segments. So what I want you to do is draw the picture here, and then just mark it up with tick marks. We know that U is a midpoint of that side. W is a midpoint of this side. And V is a midpoint of that side. It doesn't necessarily say that anything is congruent to each other. We don't know the side lengths are going to be the same. We don't know any of that. Nor do we, because it really matter to us, to be honest, in this type. But what we can do is write up the algebra. So, once you get our diagram drawn in, and once we start looking at where the tick marks and stuff go, we're going to use some very, very simple algebraic setups to finish the problem. Knowing that, excuse me, knowing that when you have a mid-segment, it's equal to half the side it doesn't touch, or if you double a mid-segment, it equals the side it doesn't touch. There's two ways to write it. Okay? So there's two ways to set this up. It just depends on what you're given, what you want to use. Fill it in. I know that UW is 4x minus 1. And I know that this whole thing is 5x plus 4. Since I know that if I double my mid-segment, what does it have to equal? Right. So algebraically, it's just picking one of these you want to use. If I double my mid-segment, it equals the side it doesn't touch. I'm glad you caught that. That's about as crazy as this stuff gets, believe it or not. I know you don't believe me yet. But when we're setting these types of problems up, it's a matter of just writing it out. Okay? When I get to this point here, let me move this up a bit. I want you guys to get in the habit of showing your distributive step so you don't forget to send it to the -1. You will forget. Don't forget. 8x minus 2 is 5x plus 4. Variables on both sides of the equation, you're going to pick on the little guy. Who are you going to pick on? The 5x. So I'm going to move the 5x to the left. At the same time, I'm going to add the 2 to the right. And I'm going to get 3x is 6. What's x? 2. But just like in most of our algebra problems in geometry, it's not just solve for x. A lot of times it's just go back and use it. So if I go back and use it, I think it asked us to say what was yv. Well, if I use 2, I get 4 times 2 is 8. 8 minus 1 is 7. 5 times 2 is plus 4 is, so that's 14 here, which means this is 7. And all three of those equal the same. That's good. Bless you.
Oh,
So now what is YB?
You add your,
7.
you add your marks?
No.
You don't have to?
No, what's YB? 7. Stop overthinking it.
No, I'm talking about for UW, you add 2 marks. After you do the.
Oh, I'm not trying to, for UW, oh, yeah, oh, I'm sorry. I thought you were talking about, gee, I took
Oh,
part
no.
3 and 3 and what? That's what I thought you were going. You can if you like, yeah. Sorry, I misunderstood what you were saying, okay? That's all this is. No,
No, see, that's everything math.
no, it really doesn't.
I'm like, okay, I know how to add. Division. What? That was me in 4th grade. Now,
Just looking.
All right, take a couple minutes to solve it.
Sure, why not?
All right, here we go. Obviously, most of you guys are setting this up fine. We know that if I double the 4x plus 5, it has to equal the 3x plus 25. Now, aside the fact that 3 times 4 is not 16, you're not the only one, so it's okay. I wasn't yelling at you, I was yelling at somebody else.
Yeah. Who else did that?
I don't know.
Me? I thought 4 times 3 was 16 first. Because I'm used to 16.
Bringing them around, 5x is 15.
I told you.
Okay. Ladies and gentlemen, come on. Substitute back in. We get 12 plus 5 is 17. If we double check it, if I go back to this side here, if I do 3 times 3 is 9, add 25 to it, you get 34, which is 17 and 17. So it worked out just fine. Okay? They're not scary problems. Boom! That's scary. This is not scary. Why not?
I need another A.
What's that?
You're still on your vinegar hands?
Yeah. No. We have things to do. This is high school. We don't do that. Or I should say, this is a high school math class. We don't do that.
I didn't know it was.
2 more examples for you to. Same deal. Same deal, guys. We're using the same diagram. There's 2 more problems. Solve them out. All right, let's go through it real quick. Like I said, most of you guys are flying through this. Let's see. EF is the 2x plus 7. Here's our 5x minus 1. So that just means I just fill it out. If I double the 2x plus 7, it equals the 5x minus 1. So I have 4x plus 14 is 5x minus 1. Don't forget to send them to both parts. Move things around real quick. You're going to get x is 15. Now, when I'm done with that, I go back to substituting because it asked for EF. Well, what's 2 times 15?
30.
30 and 7 is?
37.
Double check, make sure if you put it on the other side, you get 74. And last time I checked, half of 74 is?
37.
Yay, math.
Yeah.
Okay.
Oh, so hard.
Sure. Same thing on the other one.
Sure.
I have
Your friends here.
8x minus 2. I'll get it for you, okay?
Are you looking for me? Hey, Ben, Irene. Hi.
Daddy.
Hey, Ben. Hey, Ben.
Hey, Ben. Ben lives in this
Whatever. Suck it up. Hey, did any of you guys take? Did any of you guys just take half the 8x minus 2? You can because
Wait, so E.
Simplify. Common.
hold on, guys. Remember, there's two ways to set these things up. You can double the 2x plus 11 equal that, or take half of the 8x minus 2 to equal the other. The only time I would ever take the half part is if they're evens. But it doesn't matter. You still get the same thing. So if you double your 2x plus 11,
So could you say 4x?
yeah.
Hey.
And then distribute out 4x, 22, 8x minus 2. Moving things around real quick here, we wind up with a 24 is 4x. And we get 6. 6 times 2 is how much?
12.
12 and 11 is?
23.
6 times 8 is how much?
48.
Subtract 2 and you get?
46.
There you go.
My stomach's rumbling.
Okay? Seriously, guys, this stuff is quite literally this straightforward. Remember, mid-segments, they're equal to half the side they don't touch. They're parallel to that side. And remember how the little trick of the tick marks as these things work themselves through. Yeah, but
What's the catch? Because this is too easy.
there really isn't. As we get into the rest of this chapter, we're going to have other points of concurrency. Some of them can get a little messy. It's just a matter of keeping them straight for which one you're working with.
Okay.
Hey guys, this chapter you're going to have things that are called mid segments. But there's like 3 other ones that have vocabulary to them. So it's a matter of keeping the vocabulary correct so you know which ones do what.
Okay.
That's about the trick here. So. Yeah, if they don't give you a diagram, just draw your own. It doesn't matter. As long as you label it, that's it. Okay. Let me give you guys a couple of these to work on. Real fast. Shh. Just so you guys remember. When you go to the site, we are starting chapter 5, which means we go to the tab that says
Chapter 5.
and G. Somewhere in here there might be something to click that'll open up the textbook. Where do you think it is?
Now we're supposed to break down. I'm just going to take a wild guess.
Probably. So let me give you some homework problems. So this is, yep. Yeah. Maybe. Do those, please. Not yet. I haven't decided what we're going to do yet as far as homework. I probably won't do the homework over the weekend just because of we're probably just going to do the construction stuff and go from there. Yeah, he was telling me that. He took care of you. I don't know yet. Depends on how annoyed you make me.
Can you actually collect this? Yeah, I haven't got points for homework in like a year.
So we have a few minutes. You can at least get the first 3 of them done because that takes maybe, I don't know, 4 seconds.